Hi everyone, it's a pleasure to be there. And as mentioned, we will focus on data privacy and how we can process personal data under legal constraint. So first, as a quick introduction, I would like to explain you how we are collecting data, how we are using data, and how we are processing data. So, So at SOPHiA Genetics, we look at individuals from a multimodal angle across a range of different applications such as oncology, rare disease, cardiology. We are processing and collecting different categories of data such as clinical data, genomic data, imaging data. And our clients interact with our product through the DDM platform in particular, and which stands for data-driven medicine. The goal is really to use the data we collect to provide insights that benefit to our client firstly, and ultimately to the individuals. I invite you to visit our website if you want to look up details, but for the sake of this talk, I will just explain you in a nutshell 3 different categories of activities we may have, and what would be the legal and technical constraints. So the first general activity I would say is of course our commercial activity, the analysis of data. So as explained, we are collecting different categories of data and we provide then the relevant analysis results. The second one is the trial match activity, and the goal is really to identify one eligible profile for a specific clinical trial. The third activity is really the biopharma activity. And for this kind of activity, what we do is we really process the different network and database we have, and we try to generate aggregated data, which are the insights. But for the benefit of this talk, we will speak about one concrete example in oncology, and I will let Nataliya present it.
Thank you. Okay, so let's talk about oncology. We have, sorry, I don't see the slides. Yeah, okay, perfect, thank you. Okay, so let's say that we have an individual who has lung cancer, and that person presents himself into healthcare institution, and the healthcare institution would run DNA sequencing to obtain the sequence data. This sequence data would be uploaded to our SOPHiA Genetics platform, where we would run bioinformatics sequencing and produce sequence data. We also have a possibility for clinician to add annotation for this data. So this way we are producing genomics data. At the same time, healthcare institution can assign the individual to have PET scans to produce image data to investigate more the tumor. So the image data can be uploaded to our platform, where we would run a radiomics pipeline, which can be guided by clinician and produce radiomics data, some image segmentations. And there's also possibility in the platform for clinician to add some demographic data like age, sex, and some clinical data. So it's another modality is health data. So this is how, like in oncology, we have already 3 modalities: genomics, radiomics, and health data, which we have to handle. Another challenge in our platform is that we operate in different regions, and we have some data which, for example, are coming from the individuals in the US, individuals in Europe, and the question is how can we use this data together, and what are technical and legal constraints for this? So in this presentation, Céline will talk about legal point of view and data governance, and afterwards I will talk about technical side of how we work with this multimodal, multi-site data.
Thanks, Nataliya. So as explained, I will provide my input about the legal constraint we may face. So as Nataliya mentioned it, so the first legal constraint is, I would say, the geographical one. SOPHiA Genetics is operating in several countries, and accordingly, we are processing various data from various locations. So as part of our compliance framework, the minimum we decided to implement and the minimum regulation we have to follow is, of course, the GDPR, so the European General Data Protection Regulation. Then the second one is the Swiss Federal Act of Data Protection, as SOPHiA Genetics' mother company is located in Switzerland. And for business reason, we also decided to comply with the EPA regulation, which cover the personal health information. But this is, as mentioned, a strict minimum. Of course, depending on the project, depending on the customer, we may have to comply with additional laws and regulation. For example, SOPHiA operates in Turkey. And as you might know, in Turkey, there is a really strict data protection regulation, which prohibits the transfer of health data outside Turkey. So due to this legal constraint and really local one, we needed to adapt and to implement a specific technical architecture in Turkey to be able to provide our service and solution in Turkey. So what we did is really we created a specific architecture for our Turkish customers based on local cloud service provider in Turkey. Another constraint is more a material one, depending on the roles and responsibility we may face. For example, as part of our commercial activity, we are processing data on behalf of our customers. So SOPHiA is acting as a data processor only. For this reason, we have to comply with specific requirements, for example, from GDPR. And we needed to implement the proper contractual documentation for this purpose. As part of our biopharma activity, we decide which category of data we will process, which kind of insight we will deliver, and how we will process the data to generate the insights. So for this activity, we act as a controller. So we do have additional obligation we do have additional obligation we have to comply. For other R&D activity, I would say, we may act as controller, joint controller, or processor, depending on the project. So for this reason, from a legal point of view, we really needed to prepare different contractual documentation and to be able to provide the relevant documentation depending on the project. The first legal constraint we wanted to highlight is related to the different category we may process. As you might know, under GDPR, like pseudonymized data are still personal data. On the contrary, anonymized data are not. From EPA perspective, de-identify is no longer personal health information. So what we decided to do, and one of the key, I would say, key principle to be able to process data more freely, especially for biopharma activity, as I will explain it a bit later, is to develop aggregated data which only show general trends without identifying people directly, because aggregated data are anonymized data and are not personal data anymore. So this was I would say the three legal constraints we decided to highlight. And now in a really nutshell, I will explain you what is the compliance framework we decided to implement. So SOPHiA Genetics Data Protection Framework relies on three key pieces: people, process, and technology. For people, we appointed officially a data protection officer according to GDPR requirements. We also appointed an EPA compliance manager. We created two different committees, such as an info security committee, data protection committee, where both the data protection officer and the EPA compliance manager are members. We also implemented different processes, procedures, and policies to be able to demonstrate how we comply with the different laws and regulations applicable. And then from a technical point of view, we also implement for platform the pseudonymization process, because any and all data collected and uploaded through our platform are automatically pseudonymized through encryption process. And now Nataliya will present you at the different technical constraints we may face.
Thank you. Okay, so I will present you in a very high level how we use 4 ingredients to make multimodal, multi-site data compatible and available. So let's see that we have records of a person like genomic, radiomics, and health records in our platform. First of all, we need to make this data compatible to each other. So for this, we need to have some kind of common level of abstraction or common interface for this data. In SOPHiA, we use extension of ProfO. It's a ontology for provenance data. And in the sense of this ontology, we can say that, for example, for genomic, entity would be mutation, like gene mutation. From provenance point of view, agent would be a variant calling algorithm of certain version, and the activity would be a variant calling run. The same we can do for radiomics data. Oops. So that's why we know what data we have, where they are coming from, and we also can access this data via common interface. The next ingredient is to make data compatible not only across modalities, but also across sites. For this, we generate IDs. So for example, in genomic, we would say that there is a mutation variant like mutation 1. In radiomics, it would be image feature 1. There's some also health IDs. So all the bits information which we produce and which we store in the system have IDs. And the very important thing about this IDs that the same thing would have the same IDs across the sites. So for example, if one variant was detected in Europe, then the same variant, if similar variant is detected in the US, it would have the same ID. The next ingredient is how we're storing data. As Cécile mentioned, we cannot store data all in one place. So we have analytical backend, analytical data storages per site. So each region have their own data storage. So we have the situation when we have the data, for example, obtained in the US coming to the US data storage, data which we obtain in EU coming in EU data storage. And the question, can we use this data together? Because we cannot take some data outside of the regions. And yes, we can use a distributed query system. And distributed query system allows us to aggregate data in regions and join them cross-region. Already aggregated data, we can join cross-regions. So that's why we are not taking any sensitive data outside of regions. Also, distributed query system help us with data governance across regions. We can catalog data, we can define fine-grained access control to the data, and it also have a query review system. Let me give you a very quick example. As Cécile mentioned, that we have a clinical trial product. So if you want to answer to question like for trial match, which clients recently have seen persons with a mutation 1 and demographic 1, for example, certain age group. Since we have unique IDs across all the sites, we can run this query and receive the answer across all the sites. And once we receive the matches, we still have to deal within our legal obligations, contractual obligations and legal constraints. And Cécile will continue and finalize our talk.
Yeah, thanks. So as explained by Nataliya, once we resolve the technical constraint and when we respect the legal constraint, we are able to provide different solutions for biopharma partners. One example is, of course, trial match. And as explained, we will select the right profile for the right research study and or solution. And consequently, we accelerate the biomarker-driven profile enrollment. For this, concretely, we use the stratification of patient population through predictive algorithm based on multimodal data and analytical footprint. The key success of SOPHiA GENETICS is that we are using real-world data only. Another example, of course, is based on our network and database. We are able also to develop the needed solution for the needed institution and for the needed individual at the end. To conclude, this is the reason why back in 2019, when we create SOPHiA GENETICS and when we create our IT infrastructure, we decided to build it as part of a software as a service model. Because like this, we were able to break data silos and to generate accurate and impactful insight for the biopharma partners. So by focusing on the need to manage, secure, and accurately compute clinical data, we have been able to break the silos, and we are able also to share through our entire community the different insights we may generate. Thanks.
Thank you very much. I have a question regarding the data storage and data retention. Nataliya, you presented the way you access data from country to country. I would like to know more about the framework, the governance of data, how you store, what are the laws that you store data, and how you decide the data, the length that you keep the data, given that they are stored in different countries and probably different laws apply, privacy laws apply. And also, if you want to combine this answer with the software as a service and cloud storage, and put this answer in the spectrum of cloud storage. Thank you very much.
Thank you. I think maybe Cecile will be able to answer about the retention policy.
Sure.
But I can also say that we use relational databases to store data, the cloud-based. We don't store the personal information, like identifiable information in our databases. So.
Yes. So to complete like Nataliya's answer, so what we decided to do internally, as explained, so depending on where the client is based and where the project will be performed, we will use one of the different servers we implemented and to be able to comply. For example, in France, there is really a strict also regulation applicable to health data. So all data from our French customers and from French citizens are stored in France and or in Europe to comply with the regulation applicable. So concretely, what we do before implementing and before launching a new project, we do a legal assessment to determine which kind of regulation and restriction will apply. Then, based on this assessment, we decided where it would be okay to store the data, and we implement the relevant IT architecture. It's the same principle for the storage. So, for example, before moving forward with our Turkish projects, we implement the relevant Turkish architecture, and we were able to do it. We always provide a legal assessment, and then we build the relevant infrastructure.